Hi everyone, here is Adra, and in this video we'll learn how to create a color palette in which we will display all the available colors in Matplotlib, and after doing that we will choose a color among all the different possibilities that will be displayed in this palette, and we will use it to apply the color that we selected to a plot. Um, I mean, the choice of the color of a plot, it's, in my opinion, a really important choice, because especially if you're dealing with data analysis or you want to present the plots that you generated, sometimes it's not really convenient to just use the most classical ones like the black or red or blue colors, which are really classical, and especially when we can have in situations where we could have like multiple plots plotted together, it's best to choose like a color fashion which will, I mean, increase the effect of the graphical outcome of your presentation and of your graphs, and sometimes it could even play an important role in whether the people will feel that your presentation or your data are interesting or they are not. So for this example, we just need very few libraries and modules. I'll import first of all Matplotlib. .pyplot for plotting as built-in. I will also import another module of Matplotlib. I will import the module called colors, and I'll call it mcolors. And this is basically a module in which we can find useful functions for converting the colors from numerical codes to, I don't know, other types of formats, or for applying or taking other actions on the colors of a plot and so on. We will see during this script how it works. And then I will just import numpy, and we will use it in the end just to create two random arrays they are just useful as an example. Okay, perfect. I'll start. So as I told you, the aim of this example is to create a function in which we will generate the Matplotlib, the color palette in which we will display all the colors available in Matplotlib for some of you that may still have to know what I'm referring to. I'm referring to this color palette in which we have all the possible colors that we can apply to a plot using Matplotlib. So in principle, our aim would be to create a function that will generate and display this palette right before choosing the color to apply to a graph, in order that we can check which color suits the best for our graph, and write down its name, and so select it for the plot that we are interested in. So since we're going to define a function, I'll start by defining the name of the function, and I'll call it cell color. And then we can start within the body of the function. So first thing to do, I'm going to import into a dictionary all the colors available in Matplotlib. So I'll call this dictionary colors, and I'll define it as dict. And we have two classes of colors. So mcolors, which is the module of Matplotlib, dot base colors, which are basically just the basic colors, so blue, red, and black, I think. and yeah, very few others. And then I'll just also add, because we want all the colors, I'll just add also in this way with 2 asterisks, colors dot css4 underscore, oh here, this one, colors. And these colors are all the others that you could see in the color palette, all like this one, like dark gray or silver or I don't know, salmon, coral, and so on. Perfect. So this is our dictionary. We can also print it to see how it looks like. Let's see. Oh yeah, sorry, because I'm just defining the function, so I cannot see what it does until I call it. So sac color. Perfect. This is our dictionary. As you can see, the key are the names of the colors. So black, G stands for green, red, cyan, and all the others. These are the basic ones, and then here are the CSS4 colors, chocolate, coral, and so on. And these are the values that represent that specific color. And for the basic color, we have like a tuple with 3 numbers, while for the others we have like this hexadecimal code. Perfect. So I could just delete this. There's some space. Perfect. So the next thing that I'm going to do is to sort all this dictionary, all the items in this dictionary, and also I want to convert them. I mean, not to convert, but yeah, to convert this representation and this one, the hexadecimal one, to just one single representation, which will be the HSV, which stands for hue, saturation, if I'm not wrong, and value. So I want that my colors will be sorted according to the value of their hue, to the saturation, to their value, which stands for the brightness. So I'll just put a comment here to say what I'm doing. So sort the colors by hue, saturation, and by hue, saturation, value, and value. Okay. So to do this, I'll first take, let's see. So what I have to do, let's do the thing for one color and then I'll just go with the others. So I'll take the function mcolors, a function of mcolors. As I told you, it's a module which contains a lot of functions for converting the colors, values, and so on. And this function is to RGBA. So it converts the codes that are representing the colors that we pass into this function into an RGBA color code, which basically is a tuple of 4 numbers. The first 3 numbers are the value corresponding to the red, green, and blue, while the fourth value corresponds to the intensity. So I pass in what I want to convert, which is all the items within I will pass color for the moment, then you will understand why. And since I also want to apply another conversion, once I have the colors in the RGBA color code, I want to convert them again. And I want to convert them from RGB which is just red, green, and blue without the information about the intensity, to HSV, which is the, as I told you, hue, saturation, and value. So basically this function will change the color codes in a tuple of 3 numbers that corresponds to the hue, the first number, to the saturation, the second number, and to the brightness, the third number. Since this function accepts as input the RGB codes, it means that here we have just to take the first 3 numbers, because the first one corresponds to the brightness, to the intensity, which we're not interested into. So here, perfect. Once I have these, I want also to make a tuple with these codes, because I want a tuple that consists of the codes that describe the color, and then the second item will be the name of the color. So just a moment. I mean, name and color are not defined because they will be 2 local variables. And yeah, they are local variables of list comprehension. So for name, color in colors dot items. Okay. Let me just, yeah. I want to do these. Perfect. I have to close the parentheses also here. And then last thing to do is to sort this value, because I want to sort the values by hue, saturation, and value. So here, sorted, and all the function here. And I'll assign all the results to a variable called by HSV, because they are sorted by hue, saturation, and value. Okay, perfect. So just to repeat a little bit this, because I think it's one of the most difficult steps of this tutorial. We basically have a list comprehension, and in order to access the name and the value that are describing the colors within this dictionary here. So we access first the name with the variable name, and the color and the codes with the variable color. So we then create a tuple, and the first element of the tuple are the codes that describes each color. We first convert these all these different codes to an RGBA color codes. We then take just the first 3 numbers out of 4, because the 4th one we are not interested into, because it's the intensity. And these 3 numbers, which corresponds, if we take out the last value, they correspond to an RGB color coding, and the RGB will be then converted into an HSV color code, which is hue, saturation, and value. So we basically end up with a tuple of 3 values, and the second element of this outer tuple will just be the name of the corresponding color. And then once we have these, so a tuple that contains all and each element of this big tuple will be a tuple with 3 numbers and the name, and a string with the name of the color. And we want also to sort these elements by the values of hue, saturation, and value, so we apply sorted. Perfect. I can show you also how it looks like now. So I can just type print by HSV. Let's see if it works. Sorry, M is not defined. It's not defined. Where is M? For name, colors, I don't see. I cannot see where. Oh, here, yeah. m colors, not m dot colors. Now it should work. Sorry, again. Got to, so sorted color, m colors RGB to HSV, m colors to RGBA color. Maybe I had to, oh yeah, I think there's some confusion here with the parentheses, so I have to, yeah, 2 parentheses here, and then this one is closed, so I'm gonna have to close it here before. Now it should be done. Let's see. Yeah, sorry guys. And as you can see now, we have like this big list, sorry, and each element of the list is a tuple that contains a tuple of 3 values, which are the hue, saturation, and value of this color, and also the name of the color, which is black in this case. This is again black, and then on and on with all the others. But as you can see now, also the other colors, which before were coded in hexadecimal with an hexadecimal code, now they have the same color codes, which is fine. Perfect. I can remove it. Next thing that I'm going to do is to create a list called sorted names, in which I'll just store the name of each color. So I can say, I can apply again list comprehension. So for, and since I have to access this just created list here, I need two variables. So HSV, which is the code, comma name, and by HSV. And in this case, I will have the sorted names, so all the names of just the names, so black, K, dim gray, and so on, gray, and so on. Okay, perfect, done. Also this. Now, what we are going to do now, we basically have to understand how to generate this figure. So we will first try to understand how big is this figure, and how many lines and how many columns do we have to create. So for doing that, I first want to calculate the length of the array of the list sorted names. Then I want to calculate the number of columns. The number of columns I will not calculate it, but I can just see that there are 4. So I will call it ncols, and it's equal to 4. While I can calculate instead the number of rows, which will be equal to the total number of elements divided by the number of columns here. Perfect. So I just got the number of columns of my in which subdivide my palette, and the number of rows. Next thing, I'm going to display or create, create the Matplotlib window, and this is really easy. It's just a typical Matplotlib command. So fig.axis comma axis equal to plt.subplots, like this. Perfect. So now we basically have created the window. Now, as I told you, we have to understand how big is this window. So I'll type another comment. So we want to get the height and width of the window, or of the, let's say, of the figure is more correct. To do that, I will I will call the width x with a capital letter and the 8y again with a capital letter. And to get that, I'll just type it and then I will explain you why. Get dpi times fig dot get size and choose. Perfect. So basically this first function it returns basically the size of our figure in dots per inch, while this second one gets the resolution of the figure in inches. So by multiplying them together, we get like the size of the figure in dots, which is the information that we're currently in need of. And in the article that I wrote, you can also find the link to the official documentation for these two functions, but we are just basically using them here for this purpose. Okay, so basically big X and Y are the height, the width and the height of the figure expressed in dots. So now that we have the total height and the total width, we have to understand also how much space do we have to allocate for each colored boxes. So to do that, I'll call them like cells because they seems to be, the color palette seems to be like an Excel spreadsheet. So each color is represented by a cell. So for this reason, I'm going to write height of a cell, and the height of a cell will be equal to h, which is equal to y, capital letter, over, and I'll type and rows plus 1. I could also just do I could just divide by n rows, but I choose to write n rows plus to divide by n rows plus 1 in order to have a little bit more space in my figure. I'll show you then how it looks like in the two different situations. Similarly, I can obtain the width of a cell. Let's keep calling them in this way. The width is defined by W, and W will be equal to X, capital letter, divided by the number of columns. Perfect. What else? I think we're done. We basically obtained the height and the actual size for the space that will be allocated to each color and to each label. I just have to create an index. So I'll just type the comments here using an index for accessing all the colors, all the color names, and you will understand why later on. So k is equal to 0. This will be just an index, and that's it. So now basically we have the size we know how much space to allocate for each color. What we have to do now is to access selectively to each position and to insert the colored box in each position with its label. So okay, perfect. We can just move on and go with this next step. So inserting I will say inserting the colors in the palette. And I will specify also how, so by column. Because as you can see here, I mean the order of the colors is like black, K, dim gray, and so on. And if you check in the color palette, they are by column, so we just have to enter the colors, first filling all the first column, then filling the second one, the third one, and the fourth one. So to access each position, I will exploit a nested for loop. So the first one is this one for I in range. So the first one will refer to the columns. So endCols is the ending index. While the nested for loop here will refer to each row. So for J in range. And since we, as you can see here, we want to start by placing the colored boxes in the upper corner, we have to, I mean, if I type that the first index is 0, I'll start from here. So I want to start from the bottom, basically, so from the last row. So we have to make this for loop iterating in the reverse order. So the first index will be n rows, so the last row basically. The ending index will be 0, and then -1, just to say to go to the to the for loop to iterate backwards. Okay, within this for loop, I'll define the current row, which will be basically the row that I'm using to place my color box and my label. Sorry, why it's here. Okay, so, and I will call it row, and it will be equal to J, which is the index of the row, times H, which is, if you remember, the height of the space allocated for each color. Perfect. Very similarly, we can do the same for the column, current column, and the column is just equal to the index that defines the column. Perfect. What's now? Of course, we have to think about the labels. So I'm just defining also the height level for the color labels, for the colors labels. And I mean, this height is just y equal to row. Okay. Now, what we have to do, basically, with these three commands here, we just define the position in which we are currently working. Now we have to define like the size, the actual size of our color box, for example. And to do that, we define basically the starting and the ending position of the color box in the horizontal line, let's say. So I'll just comment position of the initial line of the initial, the initial corner of the color box. Perfect. I'll call this coordinate xi, and it is equal to, let me just write the formula and then I will be back with the description, times col plus 0.05. So this means that the initial position for the color box is equal to col, which is the first column, plus, which is, this is just an offset in order not to have the box right next to the leftmost corner of our figure. And then I'll just also type times the width of the space that we reserved from the horizontal direction for each color. So, and this is the starting position. Now I'll just copy paste this comment here, but now it's not the initial but the final corner, and so the final position will be HF, and it will be equal basically to the same thing, as you may already have understood. The only thing that is changing is the offset. So basically, if the only thing that is changing is the offset, it means that basically our color box will be will have a width of 0.2, which is the difference between these two expression, XF and XI. Perfect. Other thing to initialize is the position of the labels. So initial position of the labels, and again xi/text, and it will be the really same thing again with another offset. It will be 0.3, for example. Perfect. What's now? So now we have to find like the initial and the ending position of our color boxes and the initial position for our labels. What we have to do now is define the properties of our labels and of our boxes. Let's begin with the labels. So I will use the function axis.text, which basically generates the axis in which we can place a text, a label. I have to specify within this function the starting position, which is xi.text. I have to specify also the height at which we are going to insert this axis, and the height is y, if you remember here, which corresponds to the row that we are currently working in. And then I have to specify also the label, and the label will be sorted names, which is the list in which I store all the names of the color, and I will pass in the index k that I just defined at the beginning of this section here. Perfect. I can also go on with specification of other less important thing, like font size equal to let's see, I can just do like 80% of the height of the space reserved for the color box, so h times 0.8 is 0.8. Yeah. Let's see, another property that can be used, it's like the ones that are referring to the alignment of the text. So horizontal alignment equal left. So it means that basically the horizontal alignment. Yeah, the labels will be placed in the left corner of the. Oh, here, sorry, I was distracted because this was not the right color, so I had already closed the parenthesis. The labels will be placed in the leftmost corner of this, so in this position, basically, xi text. And what I can also add is another alignment procedure, vertical alignment equal to center, which means that it will place the label at the center of this height value. Okay, I'm done with this. So we just defined the properties of the labels, and now we have to define the properties of the color boxes. So hx, and we will create the color boxes using basically an horizontal line, and increasing its width in order to have it like a box basically. So the function for drawing horizontal lines is called hlines, and we have to pass in the vertical position, which is again y, and then the starting and the ending point of this line. So xi is the starting point, xf is the ending point. We can also specify the color, of course, and the color will be given by, again, sorted names and the index k, which defines the color of this that is referred to in this iteration. And I can also tune, as I told you, the width of this horizontal line, and I want it to be again like the 80% of the total height reserved for this color box, for the 80% of the space of the height of the space reserved for this color box. So h times 0.8. Perfect. All's closed. Okay, at the end I'll just iterate the k parameter, k plus equal 1, in order that when we end the first for loop, the inner for loop here, it means that we start with the next row, and so in the next row we will be dealing with the next color. So I can just show you, I think, how it looks like now. Let's see if it works. Oh, I have to plot it. lt.show, I think. Okay, and this this is just the first one. Am I right? And calls. Oh yeah, we have to wait a little bit. Sorry. Oh, because I was plotting here. I just have to, let's see, where is the ending, which is here. Yeah, plt.show here. And this is how it looks like. For the moment, I have to add a few other details for removing like the labels here and this framework and so on. But as you can see, it's already close to the ending result. So as I told you, now we can go out from the two for loops, and which is here, right? Yep. And place some other constraints on, like for example, the width and the height of the whole plotting figure. So or the whole axis. Sorry, ax.set underscore xlim. So the limits, the horizontal limits for the axis, and they will go from 0 to x, which is the width of the figure. Let me just copy paste. Sorry, Control Z. Y, and it's the y limits, because basically we want that the axes are as big as the figure. Perfect. And as I was telling you before, to disable the visibility of the labels of the axis, I just type ax.set axis underscore off, and this should be sufficient. Let me see whether I change something in the right direction. Yeah, as you can see, we don't have the framework anymore. Perfect. what we're gonna do now, it's let me just take it off. And yeah, I will just to add another. It's not really mandatory, but it's just for regulating the position of our figure and our axis, sorry. So I will just left equals 0. Then you will see the results, right equal 1. I'm just regulating basically the corners, the position of the corners. Top equal 1, bottom equal 0. Again, h space, which is horizontal space, equals 0, and space again equals 0. Now we are done. We should be done with the definition of the figure, and this is how it looks like. Now we are exploiting all the space because I specify like the left corner and is 0. The top corner is just 1, and we have like a little space here. The bottom corner is 0, and as you can see, we're very close to it. And yeah, and also like the others. So this is like, well, the final output. As I told you before, if at this point I was just dividing by the number of rows and not by the total height of the figure, by just the number of rows, what I would obtain is this. So the colors would have begun just at the beginning of the figure, and they would be covered by the border here. So by placing n rows plus 1, I just created a little bit more space for them. So that's it. Here we succeeded in creating the Matplotlib color palette. Now that we have successfully generated our color palette, the thing that I want to do is to print in the terminal a command in which will ask us to enter the color that we want to select from the color palette, and we will use that color for applying it to our plot. So, and this color will be stored in the variables selected color, and it's equal to, since the color values are always inserted as strings, we have to convert it in string. And so the input value, and I will just type like enter the name of the color for your graph, something like this. Perfect. And just to conclude, I want to return this variable, so selected C. So the function will basically return the name of the color that we will type in the terminal after checking the color palette that we've just created. At this point, I'll just, as I told you at the beginning, generate an X and Y array, X and Y array to plot. There are just two examples of array just to generate a plot. So X will be like numpy linspace, and I can take, for example, numbers from 0 to 50, 100 numbers, 100 values. Y could be like X cube plus 3 times X minus 5. Okay, and then let's plot them. Plotting, so figure equal to plt dot figure. Perfect. Then AX dot x equal fig dot subplots. Okay, and then well, I can just go with the standard way. So ax dot plot x, y, and then color. And so now I want to enter in this variable here the color that I just selected in this function. So I just have first to call this function and to assign the value that I selected to a variable like current. I will call it current C, which stands for current color, and this will be equal to the returning value of the function cell color that we just have finished to define. So here color will be equal to current C, and I think that we are basically done. Okay, I think that we are done with the code. Let's see if it works. Sorry, oh yeah, sorry, I have to display this to call the function before generating the figure, so it doesn't create two figure. So here, perfect. So the color palette here, we can choose the color in the palette. So let's say that we are interested in, I don't know, like this one, slate blue. Perfect. So what we just have to do once we decided the color, so slate blue, we just close the palette. Here is the question, the request, enter the name of the color for your graph. I just said that I'm interested in slate blue. Enter, and here is our graph, our plot, in the color that we selected, so slate blue. Okay, perfect. I can try once more with another color, for example, but it's just the same thing, basically. So the palette again, and let's go with the lime, for example, here. So entering the color here, lime, and here's the graph, the same graph with a different color. Perfect. I think that is it for this example. It was pretty long. I mean, the advantage of having created the function is that now if we are creating future scripts in which we want to generate the color palette for first selecting the right color to apply to our plots, we have just to call this function, which I think is a very nice thing to have it in your folders. Yeah, I think that this is it. Hope you enjoy this video and see you in another one. Bye bye.